All right, double angle formulas. And when we say formulas, these formulas come from previous formulas. Your test is going to be open note, so it doesn't really matter. But even if you had to memorize these, most people don't memorize them because, at least if they already have the sum and difference ones available. We kind of did this on block day. We rewrote sine of 2x as sine of x plus x. And then we don't know the double angle formula yet, but we know a sum formula. Sine of x cosine of x plus cosine of x sine of x. And then I don't remember if it was in every class, but in some of the classes, people are like, well, wait a minute, that's like the same thing. Instead of writing it like that, can't we just say that that's 2 sine x cosine x? Yes, you can. And so there's the sine of 2x. So it's a new formula, but it's based on an old formula. And again, in a normal year where we're having you memorize these, that's not one you really have to memorize because you just get it from the sum formula. In fact, I think most years we give you the sum, but we don't give you the double, knowing that you can come up with it if you need it. All right, let's do the same process with cosine. So cosine of 2x we could write as cosine of x plus x. Then we apply the cosine sum formula. Cosine of x minus, remember cosine is the one that's a little different, sine of x. So we could rewrite that as cosine squared x minus sine squared x. We don't often derive formulas in here, but when they're simple and straightforward like this, I think it's helpful to see where some of our formulas have come from. Tangent of 2x. I think I'll just jump to the conclusion on this one. Remember, it's tangent of x plus tangent of x. So that would be 2 tangent of x. And in the bottom is 1 minus tangent x. So 1 minus tangent squared x. All right, so those are 3 more formulas to star or highlight or box or whatever you do to draw your attention to them so that when you're taking a test you can find them easily and know what they're talking about, to know how to use them. We'll do one example, and only one example, although we'll make it a 2-part example. Let's say the cosecant of theta equals 4. And the cosine of theta is less than 0. And we want to find cosine of 2x and tangent of 2x. So our first job is to draw a picture based on this information. So we've done that several times now. That little piece of the problem was on the quiz. It's been on previous tests. It's been on previous worksheets. Cosecant. I don't like to think in terms of cosecant. So that means the sine. If the cosecant is 4, what's the sine equal to? 1/4. Flip it over. But there's two places where the sign is 1/4, right? Because sign being positive happens in the up quadrants. So that would be 1 and 2. So I don't know exactly where to draw it, except that cosine is negative. That means we're in quadrant 2 and 3. Cosine is negative. Sine is positive in quadrants 1 and 2. Yes, no? It's not a happy face. Don't nod if you don't mean it.
No, I understand a little bit.
Cosine is negative on the left.
Mm-hmm.
That'd be this way for you. Right? Cosine is negative over there. So that means I got to be over here for this thing to be true.
Okay.
But for sine is positive, that happens in the up stuff.
Oh, yes.
So I need to be up for sine, but I need to be left for cosine. So the only option that leaves me that would meet both requirements is in quadrant 2.
Okay.
So we've looked at a bunch of different ways to identify what quadrant it's in. You know, we've just said it's in quadrant 1. We've said things like it's not in quadrant 3. And here we've got a different kind of clue to help us figure out where to draw the picture. So sine is opposite over hypotenuse. Opposite over hypotenuse. The missing side, oh, this is not a nice one. We got used to those nice ones on the quiz. Pythagorean triples, but this is not a Pythagorean triple. So 16 minus 1 is 15. Square root of 15. And yet that's still not exactly correct. What's not right about it? The negative. So again, you always got to be paying attention when you're drawing triangles to put the negative on there. Okay, so this is real similar to some of the usual picture problems. Draw the picture and then worry about answering the question. Cosine of 2x. Look back at our formula, because no way we have it memorized yet, is cosine squared minus sine squared. So I look at my picture. The cosine is adjacent over hypotenuse squared. And then the sine is opposite over hypotenuse squared. So the square root of 15 squared would be 15. 4 squared is 16. Minus 1/16. 15 minus 1 would be 14/16, which would be 7/8. Is the cosine of 2x. This is pretty similar to what we've done all week. It's just a different formula to apply. But it's the same stuff. Like draw the picture, apply the formula, plug the stuff in, and be careful. Use the calculator if you want to. Tangent of 2x. So I look back at my formula. That's 2 tangent of x over 1 minus tangent squared of x. 2 times tangent is opposite over adjacent, all over 1 minus opposite over adjacent squared. Well, I guess as usual, tangent has to be the goofy one here. So in the top, I get negative 2 over square root of 15. bottom, I get 1 minus. So if I square negative 1, I get 1. If I square root of 15, I get 15. Uh, 1 minus 1/15. Well, you can get a common denominator, or maybe you just know what it is. 14/15. So I'm dividing fractions. How do we divide fractions? Keep it, change it, flip it. So keep it, change it, flip it. Let's see. The 2 and the 14 will reduce. So I've got negative 15 over 7 square root of 15. This is just like all the algebra fraction and square root rules you ever learned jammed into one problem. Multiply top and bottom by square root of 15. I don't have to worry about the conjugate though, because it isn't like 1 plus square root of 15. It's just square root of 15 that I'm worried about. So negative 15 root 15 over 7 times 15. The 15s will cancel. And I get negative square root of 15 over 7. It's like the pre-cal stuff for today isn't hard. Like we give you the formula, plug stuff in. It's all the stuff after that of all the little algebra stuff, all those rules that you worked for weeks on in Algebra 1 and Algebra 2. You know, are your skills okay to keep up with all those little bitty steps? It's easy to follow when I'm doing them, but can you do it without making any mistakes? I hope so. All right, today's assignment is worksheet 3. And it's not really that long. You might be able to finish before you leave. Answers are up here somewhere. Answers are also, here they are up here, folks in person. You guys online, they're posted in Schoology, so you can find them there.